Hey YouTube, thanks for visiting. Hope all you are doing well. So in this video, we are going to discuss the very important topic. This is Bessel function. Okay, this topic is very important for GATE, any exam, engineering mathematics exam, or simply for GATE mathematics student, and any other engineering exams, and also for mathematics exams. Okay, so this is special functions, you all know, I think, and this is a part of differential equation. Okay, so in this video we read Bessel functions, the recurrence relations of Bessel functions, and some examples, and the orthogonal property of Bessel functions. Okay, and based on that we give some examples in this video. Okay, so watch this video till the end, and before starting, I'm requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and consider subscribing to my channel. Okay, so what is the Bessel functions? So from Bessel functions, before we know that what is the Bessel function, we have to know, or we have to see this differential equation. Okay, so see the differential equation of the form x square d2 by dx2 plus x dy dx plus x square minus n square y is equal to 0, where n being a non-negative constant. Okay, it's called the Bessel differential equations of order n. Okay, so this is see, this is a differential equations of second order. Okay, so this is a very well known differential equation. So see this, if you observe these terms. Okay, so here one terms in x square minus n square, and this n gives the order of the Bessel differential equation. Okay, so now the general solution of this equation 1 is given by, so I am not going to the proof of these theorems or these functions, because this class is targeting the competitive exam students. Okay, so that's why I am not going to the proof part, okay, or descriptive part. So y is equal to, the general solution is y equal to a jn x plus b jn minus x. Okay, where jn x is equal to summation r equal to 0 to infinity minus 1 to the power r by r factorial gamma n plus r plus 1 into x by 2 to the power n plus 2r. So this is the definition, or this is known as the Bessel's functions of first kind. Okay, so jnx, so there is one another kind of Bessel function which we discuss in the next video or any another video. So this is based on the Bessel functions of first kind. Okay, so देखो gamma function, what is the gamma function? I think you all know that gamma n is equal to integration 0 to infinity e to the power minus x to the power minus n into dx. This is the definition of gamma function, and I think you all know that gamma for any non-integer quantity gamma n, this is equal to n minus 1 gamma n minus 1. Okay, I think you all know that. And one more important thing is gamma half, this value is equal to root under pi. Okay, I think you all know that. These are the basic properties of gamma functions. Okay, and for n is integer, if n belongs to z, then gamma of n plus 1, this is equal to simply this value is n. Okay, or n factorial, I think n factorial. So this is the gamma function, so which is need in this Bessel function. So because here it is the gamma function, and g of minus n x, this is equal to summation r equal to 0 to infinity minus 1 to the power r by r factorial into a gamma of minus n plus r plus 1 into x by 2 power minus n plus 2r. So that is here only n is replaced by minus n. So this jnx is called the Bessel functions of order n. Okay, so you can take screenshots of this theorem or of this function. So now the main important thing is relations, that is the recurrence relations of these functions. Okay, so first we comes to the relation between jnx and j minus nx. Okay, so the relation between jnx and j minus nx is given by this one, j minus nx is equal to minus 1 to the power n into jnx. Okay, for n belongs to z, or I think this is not belongs to z के लिए भी ये true होगा. Okay, ये मैंने ग्राफ लिखा. ठीक है. So now if we see one example which is equal to x square, so no, this is belong for n के लिए ये relation होगा. ठीक है, for any n. Okay, so see no, I think this is not, n integer हो या ना हो इससे कोई फर्क नहीं पड़ता है. ठीक है, तो देखो एग्जाम्पल क्या बोल रहा है कि x square d2y dx2 plus x dy dx plus x square minus 25 into y. So if we consider this equation, compare with this equation x square y double dash plus x y dash plus x square minus n square into y, then we get the value of n. This is equal to 5. That is, this is gives the order of the Bessel differential equation. Therefore, the general solution of the this differential equation, suppose 1 is given by a j5x plus b j minus 5 of x. Okay, where a and b are the constant and j5x is given by order 5. This is a Bessel function of order 5 and given by this function. Okay, and j minus 5x, simply we replace just 5 by minus 5. Okay, so this is the solution of the differential equation, and in case this is not necessarily integer, so this is, I think, wrong. Okay, so देखो, the most important recurrent relation in case of Bessel functions. So I just write the recurrence relation here, and so number 1 is j half x is equal to root over of 2 by pi x into sin x. Next, j minus half x is equal to root over of 2 by pi x into cos x. Next, this one j half x square plus j minus half square is equal to 2 by pi x. So 1 and 2 imply these 3. Number 4, ddx of x to the power n into jn x is equal to x to the power n jn minus 1x. Then number 5, ddx of x to the power minus n into jn x equal to minus x to the power minus n jn plus 1x. Number 6 is jn dash x is equal to n minus 1x minus jn plus 1x. This implies x jn dash x is equal to n jn x minus x jn plus 1x. Number 7 is also, that is, this is the form of these two forms are same actually. Number 7 is jn dash x is equal to n by x into jn x minus n minus jn plus 1 into x, or these two are the equivalent form of 7. Number 8 is jn minus 1x plus jn plus 1x is equal to 2n by x jn x. Okay, so x into jn plus 1x plus x into jn minus 1x is equal to 2n jn x. Okay, and number 8 is 2n 8 this is alternative form of 8, so that is we can write 2n jn x equal to x into jn plus 1x minus jn minus 1 into x. Now the most important terms of Bessel function is orthogonality property of Bessel function. Okay, so from this orthogonality property most of the questions comes, okay, in GATE and any other exams. Okay, so देखो, if lambda or lambda j are roots of jn into lambda a, this is equal to 0, then integration 0 to a jn lambda I x into jn lambda jx, okay, dx this is equal to 0 if lambda I not equal to j and equal to a square by 2 jn plus 1 square into lambda a if I equal to j. That is, this can be written is a single function a square by 2 jn plus 1x square of lambda I a into delta ij, where delta ij we all know that this is the Kronecker delta function and the defined by this. Okay, so this is very small class, and we now take some examples regarding our today's class. Okay, so this is a questions, and this is a questions from GATE exam. The question says that the Bessel's function j0 alpha k x k equal to 1 to infinity with alpha k denoting the k0 of j0 x form an orthogonal system on 0 1 with respect to the weight function. So here just it is a very basic problem that we have to know the what is the basic function. So this x, okay, this x is called here the weight function of the Bessel function. Okay, and here it is very simple question. So the weight function is here x. Okay, option C. So we don't need to anything numerical in this problem, okay, or any other calculation. Now example 2, if j0 and j1 are the Bessel functions, then j1 dash is given by. So this is based on the recurrence relation problem, recurrence relation of the Bessel functions. Okay, so which recurrence relation need? See here j0 and j1 is given and j1 dash is given. So see, we can apply this recurrence relation ddx of x to the power n jn x is equal to x to the power n jn minus 1x. See here only two functions and one's derivative is present, so that's why you have to check that which recurrence relation contains these two, basically that is like jn or jn plus 1 or n minus 1 and one of these derivative. Okay, so this recurrence relation contains our required concept or the terms. Okay, so if we put n equal to 1, then this gives ddx of x j1x is equal to x j0x, and if we simply derivative of this function, then x j1 dash x plus j1x this is equal to x into j0x. So this gives x j1 dash x equal to this one and this one. So j1 dash x equal to this one, j0x minus 1 by x into j1x. That is option A is the correct answer. Okay. Now the next question, the value of the Bessel functions j2x in terms of j0x and j1x is given by. So see here three Bessel function given, 0, 1 and 2. So see, this is the perfect recurrence relation, jn minus 1x plus jn plus 1x equal to 2n by x jnx. Okay, so if we put n equal to 1, then this gives j0x plus j2x, this is equal to 2 by x j1x, and we have to find the value of j2x. So j2x is equal to 2 by x j1x minus j0x. Okay, so I think here option D is the correct option. Okay, so this is a very small class, and I think this is the most important things, the basics of Bessel function, definition, the recurrence relation, and orthogonality property of Bessel function, and some examples of Bessel functions. Okay, so if this video is helpful for you, then obviously you like to this video, share with your friends, and don't forget to subscribe the channel. Okay, thank you, bye, मिलते हैं अगला वीडियो में.